All right, we'll be looking at the concept of calculus, right? So first things first, calculus is very wide, right? So, but I'll try as much as possible. We'll cover a lot of stuff. So we'll start with differentiation for calculus, and I'll try as much as possible to finish all the methods today. So after all the method there, we'll now look at limit, right? So after limit there, we'll look at other higher concept, please. So let's start with differentiation, please. Let's start with differentiation. All right. So let's start with differentiation. So what a differentiation, please? Definition. Differentiation can be defined. Differentiation can be defined as the change in a parameter. Differentiation can be defined as the change in a parameter or variable. The change in a parameter or variable. Differentiation can be defined as what the change in a parameter or variable with respect to with respect to another parameter or variable. With respect to another parameter or variable. With respect to another parameter or variable, please. So look up. Let's explain differentiation, please. Look up, please. Look up. So let's say I have a variable y to be equal to f of x. So let's say I have y, right, to be equal to f of x, please. From differentiation, listen, please. Listen. This thing is read y is changing with respect to what? With x. So y is a variable, x is a variable. So the change in this variable with respect to another variable is called what? The differentiation. Now here's the concept, please. If I have y being equal to x, my first derivative becomes what? I'll have dy over dx. Why am I having the y over the x? First is first, y is placed first. That's why I have y before what? There before x. What does it mean? Let's say I have z equal to f of t. What my differentiation there? I'll have what? dz over dt. Are we good now? This is literally how differentiation works. So that's the concept of differentiation. At this point now, let's look at the methods, please. Let's look at the methods. All right. Let's look at the method involved in differentiation, please. Number one, general method. Number two, we have the first principle. Number three, have the chain rule. Number four, we have the product rule. Number five, quotient rule. Number six there, we have the implicit differentiation. So these are the 6 methods involved in differentiation. We'll look at this method one after the other, please. So let's start with the first one. Let's start with the first one called general method, please. All right. Let's start with the first one, please, called general method, please. Are we good? So I said there are 6 methods involving what the differentiation, Abi. What's the first one there? General method. So let's discuss how general method works, please. Now listen, please. Listen. General method is the easiest method ever found, please. This 6 here, the easiest one is what the general method, please. Now listen to the general method, please. When it comes to solving problem under general method there, There's a key word to note, please. Please, under this, please, note something, please. Note. Note. Write this down, please. From the all right, so please, this one here is the key word to note when it comes to solving problem under what the general method. Please, what's the key word? We said multiply by the power and subtract one from the what? From the power. Please, this is the key word to note. Please, let's take an example, please. Are we good? Look up. Let's say I have y equal to x to power n. Please, I want to differentiate this using general method. What's the rule? We said multiply by what? The power. What's the power there? N, Abi. So now listen. If I have y equal to x, I have what there? The y, the x. If I have z equal to t, I have what there? The z, the t. If I have y equal to x, I have what there? I have what here? The y over dx now. Are we good? So we equal to, what's the rule for general method? Multiply by the power. What's the power there? That becomes n times Abi. Then what's next there? Subtract 1 from the power. So repeat this thing first. That becomes x to power n. Then what? Subtract 1. Please. That's all. From here, I'll have that the y over the x here should be equal to x times n times x what? Nx to power what? N minus 1. Please. That's all. That's all. Please. It's easy as multiply by the power and then what? The subtract 1 from the power. Please. Example 2. That's example 2, please. So let's say I have that y is equal to x to power 3, please. I'm asked to differentiate s cube. What do? It's easy as I'm having y here, I'm having x. That becomes what? The y over the x first. Are we good? Is now equal to, I'm asked to differentiate s cube. What do? It's easy as what? Write out the power first. That becomes 3 times subtraction from this power. How? Repeat this first. That becomes s to power 3. Then what? Minus 1. From here, what do you get here? I have 3 times x what? 3x. 3 minus 1 is what there? 2. If I differentiate s cube, I have what there? 3x squared. That's your answer, please. That's basically all about this, please. Are you good? It's as easy as multiply by the power first. What's the power first? The power here is 3. This 3 here times this. Drop this down back and then what? Subtract 1 minus 1. I have this, please. Let's take much more complex problem, please. Much more complex example. All right. Look at this, please. Let's say I have, let's call this 2. Let me call this 1. So let's say I have y equal to, observe, let's say I have 2x cubed plus 6x squared minus 3x plus 4. I'm asked to differentiate this. What do, please? It's easy. What's the concept? Multiply by the what? Power and subtract 1 from the power. Please, I'll take this man individually. Now hold on, please. I have y, I have x. All I have there, I'll have the y over the x first being equal to, what's the rule, please? Pick out this one alone and solve first. I have 2x cubed. What do we know? We said the first task what? Write out the power first. What's the power? 3. That becomes 3 times, repeat everything you have in here. That becomes 2x cubed. Then what? Subtract 1. That's 0, please. I'm done with this. Plus, I have a plus sign here. What's the power here? 2. Write out the power first. Then what? Repeat this. I have 6x squared. Then what? Subtract 1. Multiply by the power and what? Subtract 1 from the power, please. Next up, I have minus. This is my minus sign here. What do I have here? 3x Abi. What's the power here? Invisible 1, please. So that 1 that's invisible, that becomes 1 times, what I have here? 3x, then what? Subtract 1. We said there's an invisible 1 here before, Abi. Then subtract 1 from that invisible 1. Are we good? Next task, I have plus. What is please? 4 Abi. It becomes what? 0. Now listen. 4 here is called a constant term. Why is it constant? Because there's no s attached to it. Please. So any number that stands on its own is 0. Like 4 now. By differentiate 4, I have what? 0. But differentiate 1 million is what? 0. Because what is a constant term. Why is it constant? Because it does not have x attached to it. Please. Are we good? Now from here, what I get here, I'll have that dy over the x is equal to 3 times 2 is what? 6. Then x to power what? 3 minus 1 is what? 2. Are we good? Plus 2 times this is 12 x to power what? 1. Abi, I don't need to put 1 there because I expect that there's an invisible 1 there already. Next up, I have minus. What do I have here? 3. Observe 3 times 1 times 3 is what? 3. Abi, 1 minus 1 is what? 0. I have what? X to power what? 0 here, please. Are we good? 1 minus 1 is 0 now. X power 0. Then plus 0 is up, please. My final side becomes the y, the x here becomes what? 6x squared plus 12x. And to the power 0 is what? Is 1. Please bear in mind that any value to the power 0 is what? Is 1. But any value to the power 1 is what? Is that value, please. Is that thing, please. So here I have 3 times this is 1 Abi. That becomes what? I'll have minus what? 3 as my answer. So this becomes my answer after differentiating this question, please. Are we good? Yes. Any question? Let's look at yet the second method, please. Yeah, you're free. You're right. You're free. I'm free. All right. Let's do. This one is done. Let's do first principle, please. So the task says easy. Just know this keyword. Multiply by the power and then what? Subtract 1 from the power. That's all, please. Right. Alright, just come in.
Sorry, can we use this general method?
Yes, but here's the thing in exam. Exam, you can't expect this in exam. You can't say, yeah, the values are playing your life. The only thing you can see in exam, you see this man, you see it. There's no how. First principle, you see it. You see chain rule, you see this one. You can't see it because it's easy. It's easy. You can't see it, please. See, just you expect this man, please. This one will come out. Yes, it's crazy, somehow crazy, right? So that's it. Should proceed. Yeah, you can just take a picture, so later you can write it next. So what I discuss this one, that general method, and probably I'll send the video to you when I'm done. Right? Watch the video. Should proceed. From here. Next part. All right, let's look at the second method called the first principle method, please. Let's look at the first principle method, please. Let's look at the first principle method, please. So for general method there, I gave you what to note, right? I said the keyword there is what? Multiply by the power and then what? Subtract 1 from the power. And I've showed you how to evaluate problems based on this, please. Let's look at first principle, please. Now listen. Similarly, I'll give you a keyword to note here too that you use throughout the concept, please. Now, please note something, please. Note something, please. For first principle, please. Note this, please. Note this, please. Copy this down. So y add change. Sorry. So y had change in y. Are we good? So x add change in x, please. So the keyword here is that to y, anywhere I see y, I'll add what there? Change in y. And to x, anywhere I see is I'll add what? Change in x. Now, hold on, please. Hold on. Let me play with you guys more, please. Look up. Look at this plate. Look at this part, please. Look at this part, please. Hold on. Oh. If I have that y is equal to x, please, if I differentiate y with respect to x, I'll have what? dy over the x abi is equal to, if I differentiate x, all I have as my answer, please, without solving, I'll show the keyword. We said, what's the power here? 1 abi, multiply by the what? The power. That's 1 times what? X to power 1 minus 1. Am I correct? This 1 times x to power 0 is 1 abi. That's 1. That becomes what? 1. So it means that if I differentiate x, I'll have what? 1 as my answer. Using what? General method. If I now differentiate x here too, if the first principle there, I expect I should have what there? I should have 1. So I'm saying that general method and first principle are the same in the sense that their answer are the same, but the process of solving are what? Are different. General method there is a shortcut. What this one here is what there is a long procedure. But please expect this man in exam. They will stress you. Now hold on, please. Example 1 on this, please. Example 1. Let's say I have y equal to x, please. My answer should be what? Should be 1 abi. I have used general method to check what I expect to have as my answer, which is 1. Let's now apply first principle and let's see if I have 1, please. Please, the task here is that we said to y add what? Change in y, and then to x add what? Change in x. I can see this y. What do you do next there? Add a change in y. I have y plus what? Change in y, please. Are we good? Is now equal to, I can see x. What is there? Add what? Change in x. As easy as this, please. Are we good here? Are we good? Now, next step, please. I'll take this y to the what? Other side, please. That's the next step, please. Take y to the what? Other side. I'll have what? Change in y left, abi, equal to what? X plus what? Change in x minus what? Why is it minus y? Because there's a plus y here. If a plus y comes, because what there? A minus y, please. Are we good? Now, at this level, please, at this junction here, you now say, but this y you took from the question is what? Is what? X. Abi? Y is x from the question now. So anyway, I see y here, put what? X. Please. Are we good? So I have that change in y is equal to x plus change in x minus what's y? Y is x. So I have x here, please. Are we good? First task, so y add change in y to x, add what there? Change in x. When you are done, take this y to the what? Other side there. I'll have change in y equal to x plus in x minus y. Why minus y? Because there's a plus y here already. If a plus y cross here, because what there? A minus y. This y initially from the question is what? Is x. So I'll say, but this y I took last time was what? X from the question. Anyway, I see y, I'll put what there? X. So I have change in y equal to x plus change in x minus x. Question, please. If I have a minus a, what's my answer? Please, if I have a minus a, what's my answer? 0 abi. A minus a, what's my answer? Okay, then let me use a. If I have z minus z, what's my answer? Minus z abi. Minus z abi. So minus z abi. Any other opinion? Z square. Okay. Minus z square. Any other opinion? A1 abi. Now listen. These two are wrong. If I say z minus z, it means if I have 1 minus 1, what's my answer? 0. This minus is what there? It's 0. Are we good now? Are we good? Now, what do I mean in essence? The reason why I brought this concept up is that, look up. I have plus x and what? Minus x. What do you expect there? 0. So plus x will cancel what? Minus x. Why? It's 0. Please. Now, I have what left there? I have change in y equal to what? Change in x, please. We're almost done. Please, when I use this man, when I use the method, what was my answer? One, Abby. So I expect I have what? One as my answer, please. So proceed, please. Proceed from here. Now look up, look up. At this level, please. We said first tag. So y add the y to x and actually s, Abby. When you are done, you take y to the what? Other side. When you are done with that, put y as what? What is originally x, Abby? And then you cancel out, please. After cancelling out, please bear in mind that you divide through by what? Change in x. It's a procedure. The more you solve it, the more you understand the procedure, please. So I said at this level now, I'll divide through by what? Change in x. What do I mean? This one here, change in y over what? Change in x equal to what? Change in x over what? Change in x, please. Are we good? Now listen. The y over the x is the same thing as what? Change in y over what? Change in x, please. Please. So now for me, I'll have what here? What I have as my answer here? So change in y over change in x what? Is what? Is 1. So observe when I use that method, I have what? 1. First principle, I still have what? Say 1. Copy down and let's proceed, please. Copy down and let's proceed. So expect first principle in example, please. Expect first principle in exam, please. All right. You know, you always sit it. It will be there. Use. They will there. They'll tell you. Yeah. Yeah. They'll tell you. Yeah. They'll tell you today. Let's do y equal to x squared using first principle. Please, who can help me solve this thing using general method? All I have as my answer. If I have this one, what's my answer as general method? What is my answer? By now, I expect you should know how to play it. Yes, general method. What's my answer? You should know how to 2x. Yes, 2x. Yes, you said write out the power first, Abby, times what? 2x to power what? Minus 1. This becomes 2 times what? X to power 2 minus 1 is what? Is 1. That becomes what there? 2x. I expect you know how to play with this now. At this level, just master it, please. So my answer is what? 2x. Using what? General method, Abby. Let's now use what? First principle and see if the answer will be what? Will be the same, please. Let's see if our answer will be the same, please. So general method will help you do a check-in to know where you're going. Alright, that's tax there. Alright. So probably after my exam tomorrow, I'll call you guys. Alright. I don't know, I think it's morning, Sean. Yeah. Yes, I have technical drawing on Monday tomorrow. Alright, let's get exam, please. To save time, please, let's get exam, please. Please, what will I do first, please? Who can tell me, please? What will I do first? What will I do first? It's clear as what? To y, add to y. To x, add what? Change x. Go back to this place. What am I saying here? Y. No, I don't. I'll give you what to do. Don't worry. I'll give you what to do. So this is y plus what? Change in y. Am I good? Is equal to, please, for someone like you, what you do is this. You tell me x squared plus what? Change in x. Am I correct? It's connected to x, add what? But I didn't say to x squared. I said to what? Just ordinary x. Now look up here. I have x squared here. Please don't put the square. Just bring out what? Only the x, please. Plus what? Change in x. Are we good? Then the square should come out what? Outside this way, please. Bear in mind though, please. Don't go and say x squared. But it doesn't like that. Doesn't like that. You can't even, if you even write that, you can't even proceed. Please. I will go with this. What's my next tax? What's my next tax here? After I've added this and this, what I did next? I took what was other side. Yes. That becomes what? Change in y equal to what? X plus change in x All what there? All squared minus what? Minus y. Yes, we took this y other side. Please, at this level, what will I do? No, before then, this y, exactly, you said but y was, so from here, but y equal to what there? X squared. Are we good? So put y as what? X squared here. So I'll have change in y equal to x plus change in x minus what? What's y? X squared. I have x squared. Please, it's square, please. Next task, please. Go back to ND1, please. Barima theorem, please. Go back to ND1. For this one here, look up. Look up. For this one, I want to expand this bracket. How do you do it? By the way, I'll have change in y equal to, if I expand this one here, I should have x squared plus 2x change in x plus change in x squared. Then drop down your what? Minus x squared. For teaching's sake here, I will expand this. I'll show you how I got x squared plus 2x in x plus what? In x squared. Let me show you, please. Let me show you. Yeah, me? All right. So look up, please. Look up, please. Now listen. I have this man here this way. Please, if I have a squared, what does it mean? What does it mean? What's the meaning? A plus a, Abby. Talk now. If I have a squared, what does it mean? A plus a, Abby. Abby? Abby?
Yes.
Like a plus a, Abby? At this level.
It's 2A now.
Eh? At this level. Is it times A? Please, oh, a times a will give you what there? A squared, please. So it means if I have a squared, it means that thing multiplying itself twice, Abby. It means that if I have this man this way, if I have x plus change in x all square, what does it mean? It means what? X plus change in x multiplying what? X plus change in x, please. Are we good? To expand this is easy as pick out the first term in the first bracket. That's x, Abby. Multiply by everything in the what? Other brackets. That's x plus change in x. I'm done. Imagine I pick out the first one. What's next there? Pick out the what? The second one. That's what? Plus change in x into what there? Everything is what? X plus change in x. So one will sacrifice itself for the other. Pick out the first one here. The second one comes here. Then this one will be attached to it, please. When you are done, please. X times x what? X squared plus x times change in x is not change x squared. It is what? X change in x. We assume that x and change in x are what? Two different things. So x times this is what? X change in x, please. Not change x square. Because normally x times x is x square. So x times x is x. No put x square and change. No. Because we expect that x is something different. This one is what? Different. It's like saying a times b. That's ab. So x times change in x what? Change in x. X in x per se, please. When you are done, plus the same thing happens here, Abby. I will have what? X change in x, then plus what I have here? Change in x square. And now a times a square. Change in x and change in x what? Change in x square, please. Are we good? Now this is what's next here. I'll have x squared plus, observe that this and this are the same thing, Abby. If I have a plus a, that's what? 2a. All I have here, 2x change in x. There are two of it. Okay, I don't have minus here. If there was minus here, I would have cancelled it out. So I have this plus what? Change in x squared. So observe, when I expanded, I have this value. This value is what I have from here down to here. Are you good? So expand this man. I have this, Abby. Then drop down your minus and x squared, please. Are we good? Should we proceed? Sure. Now, let me just, I will leave, okay, let me clear this part. Here is not useful, right? So, starting from where? Yeah, Abby. Then this. Let's proceed, please. All right. So, look up, please. From me now, what do you observe, please? What do you observe, please? What do you observe? X squared will cancel what? minus x squared. Am I correct? Am I good? What did I say before? After you cancel, what's next? After you cancel, what did I say next? You divide through by what? Change in x after cancelling out. So let me just repeat what I have here. I'll have change in y equal to what? 2x change in x plus change in x squared. When I say what? Divide through by what? Change in x. Alright. Divide by change in x. I'll have what? Change in y over what? Change in x is equal to what? This one first, that's 2x change in x over what? Change in x. What next there? Plus, what I have here? Change in x squared over change in x. Are we good?
Yes.
This is what? Divided by what? Change in x. What do you expect? This one will cancel this, Abby. This will cancel what? This one. I have what? One left, Abby. So what I have as my answer here? Change in y over change in x is what? 2x plus what? Change in x. Observe our first example. When I divide through, I had one straight. Now, on compared to this one, I have change in x left. Now, note something, please. After dividing through by change in x, and you are still left with what? Change in x. Take it as what? At 0, please. That's the rule. After dividing through by change in x, and I still left on that one, take it as what? At 0. So all I have here, change in y, change in x equal to what? 2x. Because this one now is what? Is 0 now. So this is my answer, please. This is how I solve this, please. Are you good? This is how I solve this. This is how I solve this, please. Let's do one of fraction, right? And then from there, we'll pen it, we'll look at other methods, then we'll come back to this one again. Because it needs to be taught very well. This first principle, right? So to save time, because I said I should be doing this, so I can do this one for a whole day, and yet we're not done. So I'll try to go to other methods. Then when I'm done with this one, now come back to this one again, and then solve other examples, please. All right. Should we proceed?
Yes, we can proceed.
So which likely in there? This one, Abby? This one, Abby? Do Abby? Okay.
Did you do one? This one, yes.
This one, Abby?
No,
Let's take one more example under this, please, and let's proceed. One more example, please, on this. All right. Let's say I have, all right, example 3, right? Number 3. Y equal to 1 over x. All right. I'm asked to solve this man using what? First principle. What do you do? What do you do?
Y is equal to
Huh?
Y.
What did you hear?
Y is equal to Y.
Y is equal to y plus y. We said y equal to what?
Y
Change in y. Ó ti gbé wèé ti pẹ́. Just leave it. So look up, please. Y to y add what? Change in y. Am I correct? Is equal to 1 over to this x add what? As easy as that, please. What next here? Take y to the other side. Take this man here. I'll have change in y equal to what? 1 over what there? X plus change in x minus y. What next again? Okay.
Can I get the pen?
No. What next here, please? I will have to put y as what? 1 over x, not x, 1 over x. So, but what's y from the question there? 1 over x. What does it mean? I'll have change in y equal to 1 over x plus change in x minus what's y? 1 over x. 1 over x. Now, at this level, please listen. If I have, okay, let me just clean this part. Can I clean this part? Huh? All right. Let's first. Please keep this man. I did it so in case the man give you x plus change in x cube. How do you solve this one? Now I gave you x square, Abi. How do you solve this one? Eh? And now, how do this one in this case? And do what? Okay, shall see. All right. English part.
Yes.
All right. So after today's class, listen up. After today's class, I will try to edit the video and I will drop it on YouTube. So just send the link to you guys so you can, for the one I don't meet, so you can just learn from it. So look up, please. Now listen. I was trying to say something before. Hold on. If I have 1 over 2 plus 3 over 5, please. If I have a math problem this way, what comes to mind first? If you are good, what comes to mind there? LCM. Abi? Am I good? Similarly, look up. If I have 5 over 6 minus 2 over 3, what still comes to mind? LCM. What comes to mind here now? LCM, please. That's what I'm trying to say. If I have two fractions and I have either plus or minus in between them, what comes to mind? LCM, please. So I'll have LCM, please. Now listen. If I have LCM for two uncommon terms, like they are not the same, they are different. The two becomes what the LCM. The two of them become the LCM. I'll have change in y equal to, now listen, I'll draw my LCM line. Observe my LCM on this way, please. Now the two are not similar in any way, so the two of them becomes what the LCM. So pick out x first. X in a bracket, I'll have what? X plus change in x. So the two becomes what? The LCM. Now hold on, I'm just trying to break it down as much as I can, please. In exam, I don't need to do all these ones. I know what to go, I know what I will have. Now listen to the concept, please. I will divide everything here with the first one here. Now observe, if I divide this one with this, all I have left here, x, Abi, x times 1 is what? Is x. So I have x here. Are we good with that? Do you understand? Are we good? Yes. Now this same thing again. Okay, minus this same thing again. You divide by what? This one, Abi. This will cancel what? This. I'll have this man left, Abi. This man here times 1. I'll have that man, Abi. So I'll have in the bracket x plus what? Change in x, please. Are we good from here?
Yes.
Proceeding, please. I'll have change in y equal to x. Please, I'll use minus to expand the bracket. Minus times x is what? Minus x. Abi? Minus times plus is what? Minus. Change in what? Change in x. Are we good? Use minus to expand the bracket. So minus times x is what? Minus x. Minus times plus change in x what? Minus change in x. Hold on, let me take you back to summary 1. Plus times plus is what? Plus times minus is what? Minus times minus is what? Minus times plus is what? Minus. The way I know this thing, it is how I know it, please. So that I know it, I never forget. If they are the same sign, like they are the same sign, what's the answer? Plus. If they are swap it, is minus. If they are swap it, is minus. But they are the same thing, like minus plus. I have what? Plus as my answer. Are we good? Or we just swap it, like plus minus or minus plus. Answer is minus, please. Are you good? So minus times plus is what? Of course, minus. From here, minus times plus is minus, please. All right. From here, what do you expect, please? Okay. All over, repeat this down. X into what there? X plus change in x. Who can tell me what I do here for numerator? All I do. What can you see? What can you see here? This will cancel this. Abi now, plus x minus x is 0. So bring this down. Change in y equal to minus change in x over x into what there? X plus change in x. Are we good? Please, after cancelling out, what comes to mind? I said that in earlier now. After cancelling out, what comes to mind? Divide through by change in x, please. Ensure that after cancelling out, what next there? You divide by what? Change in x, please. So divide by change in x. I don't expect you to know it fully here, right? Just copy down the correct thing and understand them. Later, if you get home, you will revise, and then I believe you should be able to understand very well, please. Now look up. From here, I'll have change in y over what? Change in x, Abi, is equal to what? Minus change in x over what? X into x plus change in x. Am I correct? By what? Change in x. Am I good? So divide through. Divide this one, Abi, and divide this one. Are you good? For division, don't go and say minus change in x over change in x over. No. If division, just do it single this way. Are we good? Unlike what we used to do before, those are put individually. For division, don't just put just one thing in x, please. Should I proceed from here? Should I proceed? Should I proceed?
If it's like this, just
Yes, just one. If it's division, yes, just one. All right, proceed, please. Let's proceed, please. If I proceed from here, please look up. I'll have that change. Look up. I'll have change in y over change in x is equal to. Please repeat this one back. I'll have minus change in x over what? X into x plus change in x. Are we good? Now there's a way I can convert division to what? Times. Abi?
yeah.
So I'll write down times here. There's an invisible one here, Abi. So this down will come up first, and this down will come up what? Come down. So I have what? 1 over change in x. In mathematics, hold on. If I have 2 over 3 times, let's say 6 over 2. Don't look for LCM here. This here 1, this here 1, this here 1, this here 2. What can you see here? This will cancel what? This one. Are we good? Now what I have here, change in y. Hold on, please. Chief, is it recording? Look up. I'll have change in y over what? Change in x is equal to what? Minus, invisible 1 times 1 is what? Minus 1, Abi? Over what? X into x plus change in x. Am I correct? We said after dividing by change in x, and you see I have what? Change in x, still as what? At 0. So this one is 0. All I have as my answer. Minus 1 over what? X squared. If you say it's 0 now, x squared. This is my answer, please. Huh? Does not mean now. And now, see now, x is square now. That's my answer now. Are you good? So this is my answer, please. So let's move to chain rule method, please. Let's do chain rule. Now listen, you see the chain rule, product rule, quotient rule, and implicit. They have their formula. You can't solve them without using what? The formula, please. I'll give you go and cram it. Please. Cram it and pour and shaking it and go. Alright. Should we proceed?
Yeah.
Now listen, please. General method and principle are different, please. This man too is different. How do you identify chain rule? Please. In exam, they will give a chain rule question. The one won't tell you chain rule. No. If you sit, you know chain rule. So I want to wait for you. Now listen, please. Listen. chain rule method, listen, no, please.
Listen, right.
Chain rule method is only applied when you have two things in a bracket, either adding or what, subtracting, but those things are being encased in a bracket. Let me leave grammar. Look up. If I have A plus B all to power something, see, apply what there? Chain rule. Yeah. Why? I have two things in a bracket adding up and bring it to what? A power. Please. Or let's say I have P minus Q all to power, let's say, let me use A. All I apply here, chain rule, please. So identify how chain rule comes. Identify its nature. They will give you something in brackets and they'll encase in a bracket and put something what there up. That's the what? A chain rule. For instance, let's say I have that y equal to 4x squared minus 3 all to power 2. All I use here, I use what? Chain rule. I have two things, subtracting and being raised to what? A power. I'll use what? Chain rule. Now chain rule has a shortcut, but first I'll show you the long stuff first before I show you the what? The shortcut. Now look up, please. Note that for chain rule formula is given by dy over the x is equal to dy over the u times the u over the x. This one is for what? Chain rule, please. This chain rule, please. Example y equal to 3x squared minus 2 all to power 2. Please, this man is chain rule. The one I won't tell you that this is chain rule. Use chain rule. No, you should know. Hold on. Let's say an exam and I give you y equal to root 6x minus 2. Is this man general method or chain rule or first principle?
Chain.
Huh? Why is chain rule? How is chain rule? Hold on. How is this man chain rule?
Because you don't get Ake.
So because so when I was explaining, just say Ake. Huh? Go back to SS1. If I have root A, see root A. This is what? It's power what? 1 over 2. Am I correct?
Yes.
Indices. Are you good? So this means what? Y equal to what? 6x minus 2 to power what? 1 over 2. This is a what? A chain rule. You can't prove it before. Alright, please know how chain rule works, please. This is the worst they can give you. That those can find your head. This is the worst. The root concept, and I'm sure that the root has 1 over 2. Alright. Let's solve this, please. Now listen. I said there's a shortcut to this man, but I'll show you the long procedure first before what the shortcut. The shortcut, like you'll be amazed. Now look up, please. When it comes to solving problems under chain rule, what's the first task? Call the term in bracket. Call it u. Stop writing and listen, please. Call this man in the bracket. Call it what? U. So I'm saying that u is equal to what? 3x squared minus 2. First rule. Call the term in bracket u. When you are done, please. Now listen to English. If I have y equal to x, I'll have what? Dy dx, abi? If I have p, see, I'll have what? Dp dt. If I have u and x, what I have there? The u dx. I'll have what? Du over what? Ds equal to, please. If I differentiate 3s, what I have? 3s, what I have? Talk now. 6s. Huh? Which one? No, I said first tax. Call the term in brackets u. I'm still with term in brackets u. Are you good? Now, what of plus 2 is 0, abi, the constant term. When you are done with this, please, next task, I have, go back to your question, please. I have y equal to what? We just call 3x squared minus 2 what? U, abi? So I have u here, then to power 2. Are you good? Now listen. If I have y, sorry, if I have y and s, I have of x, pt, the power of t, us, the power of the x, what will I have here? The y, the u. I have y and u. That becomes what there? The y over the u is equal to, if I differentiate u square, what I have? 2u. Please. That becomes what there? A 2u. Are we good here? That's all. You are done. Record the formula and that's all. Please. Alright. Just watch, please. Watch. You are done. You said first tax. Call the term in brackets. Call it u and differentiate. When you are done, I have y equal to what there? This thing is u, then it's square. And then you are done, please. Now, at this junction here, using chain rule formula, if you want to. What's the formula there? The y over the x is equal to what there? The y over the u times the u over the x. Chief, this is recording. Alright, look up please. From here, put in values please. I'll have that the y over the x is equal to, check that thing please. What's the y over the u answer? The y is what? 2u. So I have 2u times what is one here? What I have? 6 what there? 6x. 2 times 6 is what? 12. Am I correct? Look, chief. I have what? 12 Abby. Then I have what? U, and I have what? X Abby. So I have the y over the x as what? As this. If I leave this way, it's not proper. You know why? If I have the y, the x, it means that all I'm seeing here was x Abby. Am I good? If I say I have the y over the x, I should expect what the x, everything should be x. And I'm seeing u here. And what is u? What's u? What is u? That's all. So my answer becomes 12 into what? What's u? 3x squared minus 2 and then what? X. That's all, please. That's all, please. This is chain rule, please. That's all. That's all, please. So first task, bracket u, differentiate. I have this y equal to, we'll just call this one u, then the square. Differentiate, I have this then formula. That's all. Just put it there. That's all. Should proceed. Let me show you shortcut, please. Let's do shortcut, please, and proceed on that thing, please. Let's do shortcut. Copy down. All right. So look up, please. I've actually done the videos before, but this one I'm doing now will be a summary in general. Because what I did was splitted, so this one will just be a full tutorial course on differentiation. But my phone is almost dead, so I don't know how I'll just go about it. I will solve the same question using shortcut. I'll not even use 2 lines. I'm done. Please, just watch, please. For the shortcut there, if you're good at it, it will help you a lot. Now listen. Let's work on shortcut, please. Now watch, please watch. I gave you that y is equal to what? 3x squared minus what? 2 all to power what? All to power 2. Please, when it comes to using shortcut, it's as easy as first tax, write out the power. Number 2, differentiate the term in brackets. Number 3, repeat the question. Number 4, subtract 1 from the power. Please. I said first tax. Please copy down, please. Copy down. Steps involved in solving chain rule shortcut, please. Number 1, write out the power. Number 1, write out the power. Are we good? Number 1, write out the power. Are we good? Number 2, shortcut, please, for chain rule. Number 1, write out the power. Are we good? Okay, I'm coming, please. I'm coming. Okay, it's okay, baby. I don't know. I'm coming, please. Number 1, please, write out the power. Number 2, differentiate the term in brackets. Differentiate the term in bracket, please.
The term.
The term, T-E-R-M, please. The term in brackets. Are we good? Number 3, repeat the question, please. Number 3, repeat the question. Number 4, subtract 1 from the part. That's all, please. With this first step there, you can solve any problem under chain rule using what the shortcut, please.
Number 4 is what?
Subtract 1 from the part, please. And of course, you have to multiply everything together, right? So look at this, please. Look at this, please. Going to my answer straightforward. I don't stress. I have y, I have SRB, I'll have what? The y over the x here to be equal to, what's the first row I gave you? Write out the power. What's the power there? That's 2 times, what's next step there? Differentiate the term in bracket. If I differentiate 3x squared minus 2, I have what there? 6x. I have what there? 6x, Abi. So I have what there? 6x. I'm done. Times, what's the third step I gave you? Write out the question. What's the question there? 3x squared minus 2 all to power 2. What's the last one there? Subtract 1 from the power minus 1. What I have here? 2 times 6 what? 12x into what there? 3x squared minus 2. Please check. Hey, this is x here now. I can put it here. Yeah. Please, it's crazy. So no stress. If you know this man, you can just do it instead of taking long procedure. Please. Are you good? So I'm lying now. I'll give you one to do. Please, it's easy as write out the power, differentiate, repeat, and what? Subtract from, please. It's easy, please. Very easy. Are we good? Chief, please. Is it recording? Thank you. All right. Should proceed? Let's try one more. Are you shortcut and then proceed to product rule? Right, product rule. Please, chain rule. Observe how chain rule comes. They will give you two things in a bracket. They might be adding or what? Subtracting, but there will be what? Encased in a bracket and being raised to what? A particular power. Please observe the form to which chain rule comes. In exam, they will give you, don't tell you it's chain rule. You should know. So by now, I have worded for you. Abi? I have watched eye for you. So if you see chain rule, you should know it's chain rule. All right. Should proceed? Let's try one more, please, and we'll call it a day for chain rule. We'll not look at what there, a product rule. Are we good? What am I cleaning? Yeah, Abi? Everything, Abi? All right. Let's look at yet one more example, please, under this place. So look up, please, look up. Let's say I have y equal to 4, let me just use 6x to power 3 minus 2 all to power 3. Please answer this man. This one is chain rule, Abi?
Yes.
Shortcut, please. The y over the x equal to, write out the power 3. Differentiation I have here. Problem. Differentiate 6x cubed minus 2. What I have? 9. Because 6 times 3 is 9.
18,
Abi? 80 what? 80x what? Squared now. Abi? At this level, the method should not be a problem for you. We said we have 6x cubed. What's the rule? Write out the power. Abi? 6x cubed, then what? Subtract 1. This is what there? 18x to power 2. Please, that's all. Minus 2 is constant, it's off now. What next there? Repeat what? The question, Abi? What's the question there? 6x cubed minus 2 to power what? 3, Abi? What next there again? What next? Subtract 1. Are we good? What's my answer? Multiply the what I have here. Multiply the what I have. Oh, okay. 54, Abi? 54 what there? x cube, x square b into what? 6x cube minus 2 all to power what? All to power 2. This is how you solve. This is my answer, please. That's all. This is my dy about x, please. That's all, please. Huh? Yes, now, yeah, of course, yes. Yes. Because Sabi Road. Now Sabi Road. Now Sabi Road. That's it, please. Alright. What's time? Don't give matter for what time? 420. So please, once 4:30, I'll start, please. We'll start. Just have 10 moments with you guys. Yeah, but I have to attend to them because they have exam tomorrow. Tomorrow. They're lying. And the one listen. Alright. Okay. Assignment, please. Assignment. Let's stop it here, please. Assignment. Let me just give you assignment, please. To try. Okay. Yes. Come tomorrow. Yeah. After exam, call me. Okay. Assignment, please. Assignment. So look up, please. But one. Abba, is it? All right. Use their method to solve this, please. General method. Yes. S cube. Use what? Using first what there? Principle for this one, please. Number 3. Y equal to 4x to the power 6 minus 8 all to power. Let me just give you 6. So do these 3 for me, please. Do this 3 for me. We'll meet in our next class. So this video class, I covered first general method, first one what there, and chain rule. Now next class, look at what? Product rule, quotient rule, and what there? Implicit differentiation, please. Are we good? Alright. Call it a day, please. Call it a day.